So yesterday you looked at the square root sign, which is an example of a surd. Surds, so if I said to you, what's the square root of 25? You'd tell me 5. Because, you know, if you had a square and its area was 25, the square root of 25 would tell you what the side length of that square is. But so that's a whole number. That comes out as a nice number. But there is another square that's got an area of 10. And so what side length would it actually have? Well, the square root of 10 isn't a nice number. It's an irrational number. And it approximates to 3.6227766, and it goes on and on and on. So on the left, under the square root sign, we call that an exact value. And on the right, it's an approximation. So in the beginning, we're going to just be dealing with square roots. So square roots, if you want to draw a table up like this, all the way up to probably 10 or 12 would be really handy for yourself to put in your book. So if you've got a square that's got a side length 1, its area is 1. If you've got a side length area 2, its area is 4. Side length 3, its area is 9, and so on and so on and on. These are called square numbers because they come from a square. So here's the side length and here's the area. So let's have a look at adding and multiplying. Now, if you've got normal algebra, right, 9a plus 3a is 12a, 9a multiplied by 3a, or 9 3s are 27, and a times a is a squared. So let's have a look at multiplying some surds, so numbers with square root signs. If I've got root 2 times root 9, that would give me 3 root 2. Now, where did the 3 come from? The 3 came from the square root of 9. What is the square root of 9? If you look back at that table, if this is x squared, the square root of that is 3. Okay, that's where that came from. So, the square root of 9 is 3, and I've still got to multiply it by the root 2. So we usually write that at the back. It's just like you would write the a's at the back. The letters always go at the end. If I've got, for example, the square root of 6 times 4 square root of 6, okay, I've got 4, which is this 4 here, and what is the square root of 6 times the square root of 6? The square root of 36. 6 6s are 36. But what is the square root of 36? 6. So this is actually 4 times 6, which is 24. Oops, I rubbed it out with my finger now. Put that back again. So when you multiply, the numbers under the square root sign go under the square root sign. And if you can simplify it, you do. Let's have a look at another example. 8 square root of 6 times 3 square root of 12. So 8 times 3 is 24. 6 times 12, which are both under the square root sign, 6 times 10 is 60, 6 times 2 is 12, so it's 60 plus 12 is 72. So I've got the square root of 72. Now that number is not in my list, okay, but 36 is in my list, and double 36 is 72. So you do need to be on the lookout for multiples of these square numbers. So it's actually, I could think of the 72 as 36 times 2, 36 doubled, because now I can say, what is the square root of 36? The square root of 36 is 6. So that comes outside the square root sign, and I'm still left with the square root of 2, which was there underneath the square root sign in the line above. Now I can simplify it, and 24 times 6, or 6 times 20 is 120, plus 6 times 4 is 24, so I've got 144 times the square root of 2. So you must be always on the lookout for those multiples. Let's have a look at another one. If I've got the square root of 27 on 3, 27 divided by 3 is 9. What is the square root of 9? 3. So be on the lookout for multiples. look out for simplifying wherever you can.